Okay, so this is just a review of some of the integration stuff that we've been doing so far. Remember that if we actually have upper and lower limits for the integral of f of x dx, then we can actually calculate a number. We first take the antiderivative, that's why we have a capital F here instead of a lowercase. Take the antiderivative just as if it was there weren't limits, and then we plug the limits in. And remember, we typically write this like this first. Capital F of x, no plus c is necessary. This is the antiderivative of this, as if we had just taken the integral like we'd done in the past. And then we evaluate it. You can put the bracket on this side as well if you want. Evaluate it from a to b. This is usually a good step to put in between there, because then you just have to focus on taking the integral and you plug in the limits after that. That's usually an easy way to do that. But remember, you're going to plug in the upper limit first. Notice the b here is plugged in first. The a is subtracted away from that. So remember why that is. Remember what we're finding here when we take the integral from a to b is we're finding the area under the function between the lower limit a and the upper limit b, which is this red area here. And in order to do that, we're essentially kind of starting this at 0, and we are going to subtract off the smaller area, the area just up until a, away from the bigger area that goes all the way to b, and that will give us just the part between a and b. So you do want to get the order right. You're subtracting the lower limit from the upper limit for all of these. So let's do some quick examples. These are also intended to remind you of some integration that you've haven't done in a while. So let's get started on that. All right, so let's do the integral. Let's do this one. Okay, let's do this one. Integral of x cubed plus 1 over x to the 4th plus cube root of x plus 1 over the 4th root of x dx. All right, so this is just, do you remember all of your powers and power rule tricks? Let's work on this. The x cubed is going to stay the same. This one is a 4, but it's in the denominator, so we can write that as x to the negative 4th. This one, remember what it's doing, what it would do to a power. Let's say if this was x cubed, the cube root would make this into just x to the 1. So what it's doing is it's dividing the power by 3. So really what this is x to the 1/3. And then this one is the same except with a 4 and then the denominator. So it's x to the negative 1/4. Okay. And then power rule. Oops, I wanted to do this from 0 to 1. Minor detail. Okay. Power rule, or anti-power rule, I should say. So remember, this part is where we're just getting an antiderivative. We're doing the integral of this, the integral of this, integral of this, integral of this, and just getting a function, and then we will evaluate that function from 0 to 1 in this way. Okay, so let's look at that. So x cubed, what is that the derivative of? Well, x to the 4th. The derivative of x to the 4th is 4x cubed, so this is actually 1/4 of just x to the 4th. Okay, and then again you add 1 to the power here, x to the negative 3, and divide by whatever power you get. this is a little trickier. X to 1/3, no, 4/3, sorry. Divided by 4/3, and then x to the positive 2 3/4 divided by 3/4. And that will be evaluated from 0 to 1. All right, so you may, this is a lot of review all at once, you may want to actually write out each of these a little bit differently. Let's do that. 1/4. Okay, so a lot of these, as you can see, you can bring out the negatives, and the ones that are in the denominator you can write as separate fractions. This is all going to, the fractions that are in the denominator you can flip upside down and put out front. All of this is just to make it easier to actually plug in these numbers. This is not necessarily an urgent step, but you can definitely do that to get away with it. Now it's very easy to plug in zeros and ones. That's why I chose those. So let's think about this. So this here is the f of x part, capital F of x. We're going to plug in the upper limit first. So we're going to have 1/4 times 1. 1 to the 4th is just 1, minus 1/3 times 1. 1 to the -3rd is not -3. It's 1 over 1 cubed, which is still 1, plus 3/4 times 1. Oops, that should be, it is positive, yes, positive, okay. Plus 4/3 times 1. Okay, so all I've done here, this is the first part, I have plugged in 1 for each of these values. Now for the next part, I am going to subtract. I'm going to subtract the next part, and this is the lower bound. Oops. Have to plug in the lower bound as well. So as you can see though, this is going to be 0 minus 0. Ooh. Problem. Wow. Yeah. Let's just pretend that doesn't exist right now. Let's just call this a 0. This actually is a serious problem right here, so I'll come back to that some other time. Plus 0, plus 0. So as you can see, I plugged in all the plugged in the upper limit 1 to the function, and then for the lower limit, I plugged in that. Plugged in 0 for each of these things. Yeah, I think what I'm going to do, change this is just make this into a minus x to the positive 2. That just makes these both positive. It's still a minus. Okay, that's what I wanted. Okay, so the reason that was a problem is x to the -3, if you remember, is 1 over x cubed. And you can't plug 0 into that, it doesn't work. Breaks the universe. Okay, so here's what we have, and I'll just get some space here. All right, so this is all just 0. And then you have 1/4 plus 3/4, which is 1. an actual 1, not just any sort of fraction, and then minus a third and plus 4/3 is also 1, positive. And so what we have is just 2 for our answer. All right, so here's a new one. X integral from 1 to 3 of x squared minus 1 over x dx. And this one, as you notice, is not just a simple power of x. It's a fraction with functions in the top and the bottom. So this is not going to work as simply as last time. What you cannot do is you cannot just treat this separately, this function separately, and this function separately, and just do antiderivatives of each one and then put them over the top. That doesn't work. You have to, in this case, do a little bit of algebra and split it up. So because there's only one term at the bottom here, you can actually split this fraction into 2 fractions. This is x squared over x minus 1 over x. And then you can write each of these as powers of x, and then you can actually do this. So this is the integral from 1 to 3 of x minus x to the negative 1, x to the 1 minus x to the negative 1 dx. And so what we get when we take the antiderivative of this is we get x squared over 2, add 1, divide by the power, minus, add 1 to that. Oh, wait a second. This is the exception, isn't it? If you add 1 to this, you would get 0, x to the 0, and then if you divide by 0, the universe breaks. So remember, this is a little bit of a review, but what do you take the derivative of to get 1 over x? It's the natural log of x. So this is actually ln of x. And we evaluate that from 1 to 3. And so we get 3 squared over 2 minus natural log of 3. Okay. So we've plugged in the upper limits right here. And then minus, and then you might want to put parentheses here because the minus distributes through everything. Minus 1 squared over 2 minus natural log of 1. Okay, and this again is the lower limits. We've plugged in 1 to everything. Now, natural log of 1, you can type this into your calculator, but anything to the 0 power gives you 1. So that just means that this is 0. But you can plug that in a calculator to get an approximation. 3 halves, let's see. 9 halves minus 1 half is 8 halves, or 4. So in the end, what we get is just we get 4 minus the natural log of 3. And this part didn't matter because it was 0. And we can get a decimal approximation for that, but that's the final answer.